Hello everyone and welcome back to this Python programming course where you are going to learn everything you need to get started programming in Python. In this video, we are going to look at encapsulation in object-oriented programming. So, let's get started. Encapsulation is one of the fundamental concepts in object-oriented programming. It describes the idea of wrapping data and the method that works on data within one unit. This puts restrictions on accessing variables and methods directly and can prevent the accidental modification of data. To prevent accidental change, an object's variable can only be changed by an object's method. Those types of variables are known as private variables. A class is an example of encapsulation as it encapsulates all its data, including member functions, variables, and etc. Consider a real-life example of encapsulation. In a company, there are different sections like the account section, finance section, sales section, and so on. The finance section handles all the financial transactions and keeps records of all the data related to finance. Similarly, the sales section handles all the sale-related activities and keeps records of all the sales. Now, there may arise a situation where, for some reason, an official from the financial section needs all the data about sales in a particular month. In this case, he is not allowed to directly access the data of the sales section. He will first have to contact some other officer in the sales section and then request him to give the particular data. This is what encapsulation is. Here, the data of the sales section and the employees that can manipulate them are wrapped under a single name, sales section. Using encapsulation also hides the data. In this particular example, the data of the section like sales, finance, or accounts are hidden from any other section. Encapsulation can be achieved by declaring the data members and methods of a class either as private or protected. But in Python, we don't have direct access modifiers like public, private, and protected. We can achieve this by using single underscore and double underscore. Accessing modifiers limits access to the variables and methods of a class. Python provides three types of access modifiers: private, public, and protected. Public members are accessible anywhere from outside the class. Private members are accessible only within the class, and then protected members are accessible within the class and its subclasses. So now let's look at an example. So as I earlier said, Python does not make provisions for special keywords for private, public, and protected. It rather uses single and double underscores to differentiate between protected and private members. So as we can see here, we have our class employee, dev init, self, project name, and salary. Our public member is self.name, which is equals to name, and it is accessible from any part of the code. Then we have protected, and to differentiate between protected member, we use a single underscore. So we have self.underscore project equals to project, and to have our private member, we use self.double underscore salary gets salary. Public data members are accessible within and outside of a class. All member variables of a class are by default public. That is, whenever you create a member variable of a class, it is by default public, so it will be able to be accessed from within and outside of the class. So for example, we have here we have our class employee, we have dev init, self, name, and salary. Then as public members, we have self.name and self.salary. Then public instance methods, we define a method show and taking as parameter self. So we have accessing public data members, print name, self.name, salary, self.salary. Then creating objects, we now step out of our class and we move on to creating an object of the class employee. So we have emp equals to employee, JSA 100,000. Then accessing public data members, print name, emp name, salary, emp salary. Then finally we are going to be calling public method of the class employee, which is the method show. So we have emp show. So if we save this and run, we have name, JSA, salary 100,000, representing the first print statement, and then name, JSA, salary 100,000, representing the call on the method show from the class employee. We can protect variables in the class by marking them private. To define a private variable, add 2 underscores as a prefix at the start of the variable name. Note that private members are accessible only within the class, and we can't access them directly from the class object. For example, so if we save this and run, we have an error message saying employee has no attribute salary. In the above example, the salary is a private variable. As you know, we can't access the private variable from outside of that class. We can access private members from outside of the class using the following approach. That is, we have to create a public method to access private members. So this is done as follows. So now, to be able to access the private member of the class, we can use a public method to do that. So in this case, we have our class employee, def in itself, we have our public member self.name, and our private member self.double_salary. To be able to access the salary from outside of this class, we can pass through a public method. So we have def show. Private members are accessible from a class, so print name self.name, then salary self.salary. Outside of our class, we will be able to call the public method show, which has access to the private member salary. So with this done, we will be able to have to our screen printed the salary, though it is a private member. So if we save this and run, we have name, JSA, and salary 100,000 printed to the screen. Therefore, we have been able to access the private member through a public method. Protected members are accessible within the class and also available to its subclasses. To define a protected member, prefix the member name with a single underscore. Protected data members are used when you implement inheritance and want to allow data members access to only child classes. For example, okay, so here we have our code. We have base class company, def in itself, protected member, we have self.project NLP. Then our child class, we have employee, host parents class is company. Then we have our self.name, then we have company.init self, we have our public method def show, in which we will be able to access the protected member in the child class. So out of this, we have C, our object C equals to employee JSA, then C.show will enable us to have printed to the screen the employee name and the name of the project. Nevertheless, since C is of the class employee, which is the child class of the parent class company, then we will be able to access the project name directly. So we have print project C._project, and then this will print the project name to the screen. So if I save this and run, we have employee name JSA working on project NLP, and with direct access we can have project NLP printed to the screen. To implement proper encapsulation in Python, we need to use setters and getters. The primary purpose of using getters and setters in object-oriented programming is to ensure data encapsulation. Use the getter method to access data members and the setter method to modify the data members. The getters and setters methods are often used when we want to avoid direct access to private variables and when we want to add validation logic for setting a value. For example, for this example, we have a class student with a public member self.name, private member self.age. Then we have our getter method def get age self, and when this is called it has to return self.age. Then we have our setter method def set age, which has self and age as parameters. Then when it is called, a parameter age has to be sent, which will actually replace the initial value of self.double_age. So then we have student Jessa 14. If you want to retrieve age using getter method, we have print name stud.name, then age stud.getAge, and this will give us the age of Jessa using the getter method. Then if you want to change the value of the age, we can use the setter method stud.setAge, and we give it the new parameter 16. So that will change the value, and if you try retrieving it again, we will have 16 as age instead of 14. So if I print this and run, I have name Jessa age 14, then name Jessa age 16. So our getters and setters methods function perfectly. Okay, now let's look at another example that shows how to use encapsulation to implement information hiding and apply additional validation before changing the values of object attributes, which are data members. So in this example, as I said, we are going to look at information hiding and conditional logic for setting an object attribute. So here we have our class student, we have our public member name, private members roll number and age. Then we have our public method show, which will give the student details, self name, self roll number. So then we have our getter method get roll number, which will return the roll number. Then we have a setter method to modify data member only if the condition is true. So we have def self roll number. We have if number is greater than 50, print invalid roll number, please set correct roll number. But if the number is less than 50, that is or else, then we'll be able to set that number as the value of the new roll number. So now we have our instance student Jessa 14 and 15 is her current roll number. Before modification, we will print stud.show using the public method show. We will have this information printed to the screen. And if we try changing the roll number using the setter, we have student.set roll number and we input 120. This should bring us back to this condition, and this should be printed to the screen. Then if we try setting the roll number to 25, it goes to the else part of the condition, and hence the roll number is being set to 25. If we now execute student.show, we should have 25 printed to the screen. So if I save this and run, we have student details Jessa 14 invalid roll number because we tried changing the roll number to 120. So we have please set correct roll number. Then we try student details and we put 25, and then functions perfectly because 25 respects the condition. So this is basically what the program is supposed to do, and from this output we see that it does the assigned tasks perfectly. This is basically it for this video, but before we end this video, I am going to paste a practical exercise here for you to keep learning and implementing the concept of encapsulation in object-oriented programming. The link to the solution to the practical exercise is attached in the video description below, but before you check it out, make sure you try writing the code first. In our next video, we are going to look at polymorphism in object-oriented programming.